All right, this sheet is the 5 tools that we can use to prove triangles congruent within our chapter 4. We'll also go over some of the understood congruents that you will need to continue to look for when proving these triangles congruent. So we're going to start with the top left corner triangle. And one way you can prove triangles congruent that we have been talking about is we can prove it by S, S, S. And remember, our picture might look something like this. And to prove triangles by SSS, you will need 3 sides to be congruent. So make sure that if you have 3 sides, you can automatically use SSS. The next one will be SAS, and your picture might look something like this. And remember, to use SAS, you need 2 sides of your triangles congruent, but you also need, remember we called it the included side or included angle. And remember, the included angle just means that angle is between the 2 sides. Notice those 2 sides that are already congruent kind of make up that angle that we need to be congruent. The next one we may use is ASA, and your triangle picture may look something like this. Remember, to use ASA, we need 2 angles that are congruent. And again, kind of like the SAS, we need that included side. And remember, to be an included side, we need to be between, in the middle, kind of those angles wrap around the outside of the included side. So make sure that you are able to recognize what side you actually have. The next one may be your HL theorem. And remember, the HL theorem is for right triangles only. So unless you have a right triangle, you do not need to worry about this one. The 3 things we need here is a right angle, which a right angle will make up that right triangle. We also need, kind of like the name itself, H stands for the hypotenuse. So the triangles need their hypotenuse to be congruent. Remember, that's the side that is directly across from that right angle. And we also need a leg, and it doesn't necessarily matter which leg you have, but the legs that are congruent need to be corresponding. All right, and the final one that we have gone through and talked about is AAS, and your picture may look something like this. And remember, in this one, it's very similar to ASA because you have 2 angles that are congruent, but the difference is we need the non-included side. And the non-included side is just going to be that side that doesn't fall within those 2 angles. So notice that this side that we have in our picture is on the outside. Now, I'm giving you one triangle because remember, you want to use one of these 5 from your picture, but you only need to be labeling it from one of the triangles out of the 2. So just make sure these corresponding parts are congruent, and you have, remember, also drawn on your picture. That will be very beneficial. Now, the 2 things that I continue to stress in your picture to look for are 2 different things. The first thing, we'll start over here to the left. Remember, we need to always be on the lookout for vertical angles, because vertical angles will always give you congruent angles no matter what. So in this picture, one of your students or your classmates said it looks a lot like a bow tie, and for the majority of the time that is going to be a true statement. Not always, but most of the time. So we might say that angle ABE is congruent to angle, and notice A over here matches with D below because of the corresponding side. So we would say DBC, and I need to make sure that I mark those angles. So if those angles are congruent, the reason behind that would be in your proof, vertical angles theorem. All right, so that's one of the things that I continue to stress, that we can always find, or most of the time find, one of these two things in our picture. The second thing that I continue to ask you to find is your reflexive property. And reflexive property is understood that a side will be congruent. So in this picture, looking at your corresponding parts, I can see that down the middle, they share that side. EG is a common side for both triangles, but I have to remember to label it correctly. EG is actually congruent to GE in this picture because of the reflexive property of congruence. Another way you may see the reflexive property might be in a triangle. Let me draw that center line. Notice that these two triangles look very much like they are back to back, is kind of what we had been talking about in class. So when I go to label this reflexive property, I may label it as HJ is congruent to HJ, giving me that congruent side itself. Now, those are some things in the toolbox. Now, because we have a little bit more time on the video, let's go over some things that you may see within a proof and what are your next steps. So, remember we talked about if I see perpendicular lines, which may be my given, remember my next thing is going to be my angle and my other angle. The angles that those perpendicular lines make are going to be considered right angles. And I have to do that step first because then my next step can be that my angles are congruent. So my reasoning behind step 2 is because I talk about perpendicular lines, that's what I'm going to put over here. Definition of perpendicular lines. And then my statement or my reason for number 3, you can put a couple things down. I always put all right angles. Erase that. All right angles are congruent. Just because that's what I say when it goes through my head. Some other things that we might look at when we look at a proof, or we may see, if I know that maybe even in this picture, I know that J is the midpoint of IK, which is given. Remember, a midpoint is always going to kind of split that side that I'm talking about in half. So when I split up a segment, I'm going to get two congruent segments. So I can say that IJ is congruent to KJ. And remember that we use the definition of a midpoint for this one. Because I talked about a midpoint in my original statement, I can go ahead and use that in the next statement. Let's see. Another thing that we have talked about might be parallel lines. And remember that not all parallel lines are congruent, so we have to make sure we don't take that we don't always think that because they might not always be congruent. They might just be parallel. Remember, parallel lines, for the majority of the time, are going to give us congruent angles. That's really all we've looked at this chapter. And we've looked at those angles because of alternate interior angles theorem. So those are three things that I think are going to show up more times than not, and you should be prepared to write those next few steps. And the last thing that we have talked about that you should know, if we know that a line is bisecting an angle, and that's our given, our next step gives us two congruent angles. If I bisect a candy bar, I get two congruent candy bars. That would be nice. If I bisect a segment, I'm going to get two congruent segments. If I bisect an angle, I'm going to get two congruent angles. And because I'm talking about bisecting, oh, that's funny. It's going to be the definition of a bisector. Those are just some helpful hints: vertical angles, reflexive property, perpendicular lines, parallel lines, bisecting an angle. And then remember over here, the midpoint, those are the steps in the process to kind of extract or pull out some things from your given information. I do hope this helps. There will be one more video for you to watch to fill out the back of your study sheet and to kind of go through all of the concepts from Chapter 4.